Hi everyone, in this lesson we're going to be looking at logarithmic functions and how to graph them. So in this first box, I just have the properties here of a logarithmic function. As a reminder, the domain is the set of numbers greater than 0 to infinity. The range includes all real numbers. The x-intercept of the graph is 1, and there is no y-intercept. The y-axis, x equals 0, is a vertical asymptote. A logarithmic function is decreasing if a is between 0 and 1, and increasing if a is greater than 1. And then if we consider the base, in this case log base a, we will have points on the graph 1 over a. So if we were saying log base 10, it would be 1/10, -1, 1, 0, and 10, 1 would be points on that graph. The graph is a smooth, continuous graph with no corners or gaps. All right, so we have a vertical asymptote when we're talking about logarithmic graphs, but we're never going to have a horizontal asymptote because the range is the set of all real numbers. So no horizontal asymptotes to deal with when graphing logs. Now, we're going to practice lots of graphing, all right? And there's a couple of steps that I want you to follow. Number 1, graph the vertical asymptote. So the vertical asymptote is found by looking at whatever the value is with x. And notice that the format is x minus h. So our vertical asymptote is going to be x equal to h. So whatever sign is in here, you're going to take the opposite to do the vertical asymptote. For the parent function, the vertical asymptote is x equals 0 because the value of h is 0. Next, we're going to find the x and y-intercepts. To find the x-intercept, we set y equal to 0. To find the y-intercept, we set x equal to 0. And then we'll plot a few more points and we'll do the graph. So number 1, sketch the graph of y equals log of x. So starting off nice and easy. And we have no h value, the value is 0. So in this case, our vertical asymptote is x equals 0. Now we're going to find our x-intercept by setting the whole equation equal to 0, making y 0. And if we convert that to exponential form, we get 10 to the 0 equals x, and anything to the 0 power is 1, except for 0, 0 to the 0 power is undefined. So we know that our x-intercept is at the point 1, 0. Now for our y-intercept, we're going to let x equal 0. And hopefully you'll remember that the domain of a log has to be greater than 0. So this will not work, and that means that it's undefined. So let's make a note here, undefined. And we do not have a y-intercept, none. Some coordinates we can find using our calculator. Once we've typed it into y equals, we can go to the table of values. And we know that before 0, we're going to have errors. Right, so the first thing I like to do always is draw in my vertical asymptote. And you might want to use a highlighter or a colored pen to do this. And then we're going to go ahead and plot our points. And we're going to sketch the graph. Now be really careful, because if you were to look at the graph on your calculator, it looks like the graph kind of stops right here, but it doesn't. It continues infinitely, getting closer and closer to the vertical asymptote, but never touching it. So be careful when you do your graph. Now that I have my graph sketched out, I want to just identify my domain and range. So the domain is all the valid x values, and those are going to be greater than 0. not including 0. And the range is going to be all real numbers. Right? The range is everything that is included in y values. Right, now that we've taken a look at a graph of a basic function, let's step it up a little bit. We're going to look at the vertical asymptote first. So you want to notice what's happening in here, where the vertical asymptote is going to be the opposite of what is in there. So we have a positive 3. So our vertical asymptote is going to be at x equals negative 3. For our x-intercept, we're going to set the entire equation equal to 0. Put it in exponential form. We assume the base is 10. When it's not written, it's 10. 10 to the negative 2 minus 3 equals x. And so in this case, x is approximately negative 2.99. So we have an x-intercept at negative 2.990. I'm going to add that to my table. The y-intercept is found by putting in 0 into your equation for x. And we can just put that in our calculator, the log of 3 plus 2. And you're going to get y is approximately 2.48. So we have another coordinate at 0, 2.48. At this point, I think I'll add a point by using my calculator and looking at my table of values. I'm going to also plot the value of 1. At 1, our y value is 2.6. All right, so I'm going to plot that. Then we'll evaluate what the domain and range is. All right, we have our graph drawn, and we can see that the domain is going to include anything after the value of negative 3. So negative 3 to infinity, and the range is all real numbers. We're including all the y values. Let's take a look at the next one. Now, it doesn't matter what base we're talking about when we're looking for the vertical asymptote. For number 3, we have log base a, ln. The vertical asymptote will be the opposite of what's inside with the x. So we're going to have x equals 2. We can find the x-intercept by setting the entire equation equal to 0. Remember, ln is log base e, so before you convert it to exponential form, you may want to rewrite it as log base e. So then it's e to the first equals x minus 2. So x is equal to e plus 2. So x is approximately 4.72. So 4.72 is our intercept for x. Our y-intercept can be found by putting in 0 for x. When we put ln of negative 2 into our calculator, we're going to get an error, remember, because the domain of a log is greater than 0. So this part right here is going to cause an error. It's outside the domain. So this would be undefined. And we do not have a y-intercept. You could put the graph into your calculator and pull off some more points. I decided on 3, negative 1, and 6.39. I'll do my graph before I evaluate what my domain and range is. We're going to have my graph. I'm going to look at my domain. My domain is going to be all x values that are greater than 2. and my range is including all y values, so this is all real numbers. Our vertical asymptote, we're going to take the opposite of what is with the x. So we're going to get x equals -3. The x-intercept is found by setting the equation equal to 0. You could really just say I'm going to multiply by a negative or divide by a negative, and that would take care of that for us. So we end up with log base 2 of x plus 3 equals 0. Now we'll put it in exponential form. 2 to the 0 equals x plus 3. 2 to the 0 is just 1, and then 1 minus 3 gives us -2. So we get x equals -2. So we have an intercept at -2, 0. Y-intercept is found by putting in the value of 0 for x. So we end up here with a negative log base 2 of 3 is going to equal our y-intercept. And if we put that in the calculator, we're going to get a value of y is approximately -1.58. So we get 0, -1.58. All right, we're going to sketch the graph, and then we'll decide on the domain and range. I'm going to pick another point just so I can have a really accurate representation of the graph. I'm going to go with 5. I can look at my table of values in my calculator. For x is 5. I'm going to get -3. My domain is going to be all the values greater than -3. My range is all real numbers. All right, hopefully you're starting to get the hang of this. I would pause the video and try number 5 on your own and come back when you're ready. Vertical asymptote here, we do not have a value of h, which means we have a value of 0. So in this case, our vertical asymptote is x equals 0. The x-intercept is found by setting our equation equal to 0. Subtract 1 from both sides, and then I'm going to just divide by a -1. And then we're going to put this in exponential form. So 10 to the first equals -x. So x equals -10. So we have an intercept at -10, 0. We find the y-intercept by setting the value of x equal to 0. Remember, the domain of a log has to be greater than 0, so we have a problem right here. So that makes this undefined. So there is no y-intercept. All right, I'm going to sketch the graph. Oh, let me add in a few more points. I'm going to go to my calculator, look at my table of values. I'm going to pull off -5 and -1. At -5, we're at 0.3. And at -1, we're at 1. Right, using our graph as a guide, the domain looks like it's everything up to but not including 0. So from -infinity to 0, not including 0. And the range, as always, is all real numbers. For number 6, I would say again, pause it, try it, and then come back to the video. So we have a sketch of log base 1/3 of x. We have a value of 0 for h. So that means we have a vertical asymptote at x equals 0. I'm going to go ahead and add that onto my graph right now. X-intercept can be found by setting the equation equal to 0. Put it in exponential form. So we get x equals 1. So we have an x-intercept at 1, 0. Y-intercept, we're going to substitute in 0 for x. This is going to be outside our domain. The domain of a log is greater than 0. So this is undefined. We have no y-intercept. Right, some other points I'll pull off are going to be 5 and 9. And again, if you're worrying about what points to pull off, look at the graph and just, make sure you pull at least 3 points that are going to help you accurately display what you're seeing on your calculator. So I picked 5 and 9. And now I'll do my graph. You can see by looking at the graph that the domain is all values greater than 0. And the range, as always, is all real numbers. All right, last little bit here of this lesson looking at translations of logarithmic functions. And we've talked about it at the beginning of the lesson, and we've been examining the graphs, right? If we are going up vertically or we're going down vertically, a vertical shift is always going to be denoted by this value of k. So shifting vertically. Shifting horizontally is always going to be denoted by this value of h. Stretching vertically is going to be this value a. If a is between 0 and 1, it's a compression. In IB, we call it compression. We also, refer to this as a shrink. So a compression, aka shrink. And if we have a negative in front of our a, in other words, if our a is less than 0, we're going to be reflecting over the x-axis. If we have log base b of negative x, the parent function is going to be reflected over the y-axis. So if that negative is inside the parentheses with the x, that would be a reflection about the y-axis. Now, this shouldn't be too intimidating because we did a lot of translations with functions in Algebra 2, and translations of functions work the same no matter the function. All right, so hopefully most of this is familiar to you. So let's go over letters A and B. For each of the following logarithmic functions, describe the transformations from the original parent function. All right, so first of all, we have that 1/2 out front. So we are going to have a vertical compression by a half. Okay, so that takes care of the half. Then we have that -4 in there. That means that we are going to go right 4. Remember, it's always the opposite when it's inside the parentheses. And then we have the +3. That means the whole function is going to go up 3. All right, let's take a look at letter B. We have a negative out front. That means we're going to be reflected over the x-axis. That's the negative. The 2, so we are going to have a vertical stretch by 2. The +4 means that we're going to move left 4. And the -5 means we're going to move down 5. All right, that's everything we have for this lesson. Hope you enjoyed it. We're going to do lots more practice. So have a great day, everybody.